Hello everyone, in this video I will share with you how to determine deflection of beam with overhangs with multiple loads. In this problem, we need to identify the maximum deflection. Before beginning Macaulay method, we need to calculate the reaction. Okay, we calculate the reaction at B and reaction at E. So we're taking moment at B equal to 0, RE times 8 plus 40 times 2 minus 10 times 2 times 2 plus 2 divided by 2 minus 40 equal to 0. So RE is equal to 2.5 kilonewton. Then using summation force equal to 0, so we have RB plus RE equal to 40 plus 10 times 2, so we can find that RB equal to 57.5 kilonewton. With the reaction calculate, we begin by drawing an elastic curve. Okay, so we draw based on the reaction. So we know that the elastic curve look like this. Okay, then we find the moment function. In this problem, you can choose either to cut from the left or right. So in this case, I will cut from the left to the right. So I choose from the left to the right. Since we're dealing with a UDL, we must extend the UDL load beyond point D to end of beam. Okay, beyond point D to end of beam. Then we must put an upward load from D onwards to cancel the effect of the extra load. Okay, upward load. Okay, I'll cut at the end of the span. Okay, then I draw free body diagram. Okay, so 57.5. Then you have the one 2.5. Okay, so start from the left. Okay, the extended of loading. M. Okay, so I know this one is 2, 2, 2, and 4. Okay, we're taking moment 0 mx plus 40 times x minus 57.5 times x minus 2 plus 10 divided by 2 x minus 4 power of 2 minus 10 divided by 2 x minus 6 power of 2 minus 2.5 x minus 10 equal to 0. So this UDL is 10 kilonewton per meter. Okay, next we need to find slope and deflection equation. I d square v over dx square to normal function is equal to negative 40x plus 57.5 x minus 2 minus 5x minus 4 power of 2 minus 5x minus 6 power of 2 minus 2.5 x minus 10. Okay, we integrate. So we have 2x power of 2 plus 2.5 divided by 2 x minus 2 minus 5 3 minus 5 over 3 x minus 6 power of 3 minus 2.5 divided by 2 x minus 10 power of 2 plus c1. Okay, then we integrate again to find the deflection equation. Okay, negative 20 divided by 3 power of 3 plus 57.5. Okay, this is power 2. Okay, divided by 6 x minus 2 power of 3 minus 5 divided by 6 x 4 power of 3. Okay, right, sorry, this is 5 divided by 12 power of 4. That's 5 divided by 12. 4 minus 2.5 divided by 6 x minus 10 power of 3 plus c1x plus c2. Okay, in this case we only have two equations. Okay, now we need to solve the unknown of c1 and c2. Okay, by apply boundary condition. So let's take a look the problem figure. Okay, in here we have pin support and roller support. So the boundary condition is v equal to 0 when x equal to 2, and one more v equal to 0 when x equal to 10. Okay, so now we calculate to find the unknown c1 and c2. Applying boundary condition. So we have a boundary condition v0 x equal to 2 and then v equal to 0 x equal to 10. So in this case we substitute both equation into equation number 2. Okay, let's we substitute into equation number 2. We have, okay, we start with the first boundary condition. Okay, x is 2, minus 2, 2 minus 4, 2 minus 6, 2 minus 10, then we plus c1 times 2 plus C2. Okay, so in this case, we know that this is 0. 2 minus 4 is negative 2. For Macaulay method, we need to cancel up. Okay, whatever you have, you got negative value in the bracket. So therefore, so this is 0. Therefore, you will get 2C1 plus C2 equal to 160 divided by 3. So in this case, you have next equation. So I write down is as equation number 3. So next, I will substitute the second boundary condition here. 20 divided by 2 times with 10 power of 3. Okay, write down again all the equation. Okay, 10, 4, 10 minus 6, 10 minus 10, plus 10 times C1 plus C2. Okay, so this is a 0. So you know that this is a 0. So this is a 4. This is a 6. And this is a 8. So when you calculate, you will get 50 divided by 3. So you have another equation. Equation number 4. Then subtracting equation number 3 from 4, it will give C1 is equal to 267.5 and C2 equal to negative 481.7. Thus we rewrite again the slope and deflection equation. So first we write equation of slope, negative 20x power of 2 plus 7.5 divided by 2 x minus 2 power of 2 minus 5 over 3 x minus 4 power of 4 plus 5 over 3 x minus 6 power of 3. Okay, sorry, this is 3 plus 2.5 divided by 2 x minus 10 power of 2 plus 267.5. Okay, then equation of deflection 3, 7.5 divided by 6. 3. Sorry, this is 5 divided by 12. 4 divided by 12. 4 plus 2.5 divided by 6. 10 power of 3 plus 267.5x minus 481.7. Okay, so from the problem, okay, back to the problem, we are interested in finding the maximum deflection. So we examining based on elastic curve. The overall maximum deflection will be the biggest of at point A. Okay, point A, as you can see here, point A, and then point F, which is in here, delta F, delta A, and then it can be the deflection between point B to point E. So in here, so we don't know where is the location of deflection between B and E. We start find the deflection between B and E. Okay, so we solve by using the equation of deflection. Right, so as you can see in this equation, we cannot solve algebraically for x. So we need to use trial and error. Okay, from the elastic curve, that the maximum deflection initially choose the midspan where x equal to 6. The maximum deflection for this region when dv over dx equal to 0. So we need to find slope equal to 0 when x, we try when x equal to 6. So we substitute into the equation number 4. Okay, 6 minus 2 power of 2, 5 over 3, 6 minus 4 plus 6 minus 6 plus 6 minus 10 plus 267.5. So you know that this will give a negative, so we cancel out. Okay, therefore, we'll get dv over dx is equal to negative 5.83 divided by EI. So in this case, right, this not close to 0. We need to find dv over dx approximate close to 0. So we need to reduce to get dv over dx approximate close to 0. So we start again by try the next one. I start with x equal to 5.8. Okay, I substitute 5.8 to equation number 4. Okay, 5.8 to 5.84, 5.8 minus 6 plus 2.5 to 6, 5.8 2 plus 267.5. So this will give 0. Then we can find dv over dx is equal to 0.13 pi. So in here we can see is approximately equal to 0. Okay, we need to find the maximum deflection between point B and E. Therefore, we will use x equal to 5.8. Since it's close enough, but you can check this by linearly interpolation between the values. Okay, by using x equal to 5.8, we substitute into the equation number 5. So IV next for BE when x equal to 5.8. So 26, x is 5.8, 57, 5, 6, 5.8 minus 2 of 3, 5 over 12, x, kx is 5.8 minus 4, 7. So when we calculate, okay, so of course this is negative, so you will get a 0. So when we calculate, we get V equal to 290.5 EI. So it's given EI, just we will get 290.5 divided by 20 times 10 power of 3, get 0.001453 meters. So it's positive, it's going up. Okay, next we find deflection at A. Okay, deflection at A. So we know that deflection at A when x equal to 0. So EI V A x equal to 0. We substitute into the equation. Okay, cos it's 0. Okay, 0 minus 4. That's 5, 12. 0 minus 6. 0 minus 10. Okay, plus with 267.5 times 0 minus 481.7. Okay, so we cancel out everything in here is 0. So we can find that VA is equal to negative 481.7 divided by EI. So it's equal to negative 0.002409 meters. So it's negative. The deflection is going down. Then we define the deflection at point F. So deflection at point F when x equal to 11 meter. So EI VF x equal to 11. Okay, substitute 11 meter into the equation of deflection. Okay, 11 minus 2 power of 3 minus 4 power of 4. 11 minus 6 power of 4 plus 2.5. 6, 11 minus 10 power of 3 plus 267.5. 11 minus 481.7. So we can find VF is equal to negative 165.9 EI. So it's equal to negative 0.00083 meters. So it's negative, it's also going down. Okay, by inspection. Okay, we write again for VBE, then VA and VF. Okay, VBE is equal to 0.001453 meter. And then for VA is, what about PA? Okay, negative 0.002409 meter. Okay, for VF, negative 0.00083 meter. Okay, so it's going up, going down, down. Based on these three values, we can see that the maximum deflection is at point A. So this will give the maximum deflection. Therefore, delta max is equal to negative 0.002409 meter. Okay, that's all for now. Thank you for watching.